Hello friends, in the chapter of differentiation we have studied the definition of derivative, right hand derivative and left hand derivative. Then we have studied the relation between differentiability and continuity, that is differentiability implies continuity. Then we have studied the geometrical interpretation of derivative, that derivative represents slope of a tangent. We have examined a given function for differentiability and continuity. Now we shall study another type of functions which are known as hyperbolic functions. Here I have written the definition of hyperbolic functions. We shall see the definitions and some identities of hyperbolic functions I have written. We will see these definitions and identities, and then we will see what is the relation between hyperbolic function and circular function. Now hyperbolic functions are defined as follows in terms of exponential function. E raised to x or e to the power x is an exponential function, and the hyperbolic function are denoted by this symbol h. H stands for hyperbolic. For circular function we have only sin x or cosine x, but here we will have hyperbolic sin x, hyperbolic cosine x, and that are denoted by this h letter. So we read this as hyperbolic sin x. Hyperbolic sin x is equal to e to the power x minus e to the power negative x divided by 2. Second thing, hyperbolic cosine. Hyperbolic cosine is defined as e to the power x plus e to the power negative x divided by 2. Now see, these two are the main hyperbolic functions. For hyperbolic sine, there is minus sign between e to the power x and e to the power negative x, and for that is divided by 2. And for hyperbolic cosine x, these two functions are added. Here these two functions are subtracted. That is the difference, and both are divided by 2. So these are the basic definitions of hyperbolic functions: hyperbolic sine and hyperbolic cosine. And with the help of these hyperbolic sine and hyperbolic cosine, the remaining 4 are defined, and that is hyperbolic tan x, which is similar to circular function, hyperbolic tangent or a circular tangent. Circular tangent we have the definition as sine upon cos. Similarly here, hyperbolic sine x divided by hyperbolic cos x. Circular sine we write only sine x, and hyperbolic sine we write sine hx. This stands for hyperbolic. Read like this: hyperbolic sine x. This is only sine x. That is the difference in circular and hyperbolic functions. Now you see, hyperbolic tan x is hyperbolic sin x divided by hyperbolic cos x. And here we have these definitions: hyperbolic sin divided by hyperbolic cos. So this denominator 2 cancels, and we get e to the power x minus e to the power negative x divided by e to the power x plus e to the power negative x. That is hyperbolic tan x. And what about hyperbolic cot x? That is hyperbolic cos x divided by hyperbolic sin x, and this is equal to see, this will be at the numerator, e to the power x plus e to the power negative x divided by, and this is at the denominator. So this is a definition for hyperbolic cot x. Now hyperbolic sec x is 1 divided by hyperbolic cos x, and that is reciprocal of hyperbolic cos x. The reciprocal of this 2 is the numerator, and this function is at the denominator. And hyperbolic cosec x is reciprocal of hyperbolic sin x, or 1 upon hyperbolic sin x, and this is reciprocal of this, that is 2 divided by e to the power x minus e to the power negative x. So these are the 6 hyperbolic functions that we have defined. And these functions, for domain for these functions, see, hyperbolic sin x, hyperbolic cos x, hyperbolic tan x, hyperbolic sec x are defined for all real values of x. X belongs to R means R is real number set and x is a real number, and only there are two are separate here, that is hyperbolic cortex and hyperbolic cosec x are defined for non-zero values of x, real numbers, non-zero values of real numbers, non-zero x which is in R. Why the non-zero is required here? What happens if x is 0? For hyperbolic cortex, you see, if x is 0, this will be e to the power 0, that we know it is 1, and this is again e to the power 0, that is 1. 1 minus 1 is 0. The denominator becomes 0, so therefore this function is not defined for x is equal to 0. So here x is not equal to 0 is the condition. And similarly for cosec here the same denominator is there, and this is 0 when x is 0, so therefore this function is not defined for x is equal to 0. And other functions are defined for every real value of x. So thus these are the definitions. Among these 6 definitions we have to remember only these two, because other can be written in the terms of hyperbolic sine and hyperbolic cos as like the circular function. So after this we shall now see identities of hyperbolic function. Now I have written this identity hyperbolic cos square x minus hyperbolic sine square x is equal to 1. Now what is the identity for circular function, trigonometric function? Cos square x plus sine square x is equal to 1. Here it is hyperbolic cos square x minus hyperbolic sine square x is equal to 1. There is minus sign. For circular function it is plus sign. Now why this difference is so, that we shall see. For circular functions, trigonometric functions, or which is also known as circular function, we have a circle, unit circle, and the center is at origin, the radius is 1. And if this is x-axis and this is y-axis, its origin, the equation of this circle will be x square plus y square is equal to 1. And if you consider a point on this circle, any point on the circle, and suppose the coordinates of that point are taken as cos t, sin t, and if you join OP, then this angle will be t. And you see this point lies on the circle, because what we have the equation of circle is x square plus y square is equal to 1, and we have cos square t plus sin square t is equal to 1, identity for circular function, and that satisfies the equation of circle. Therefore this point lies on the circle, and therefore these trigonometric functions are known as circular functions. The unit circle is the corresponding curve for the circular function. And now why these functions are called hyperbolic? For hyperbolic function, we consider the hyperbola x square minus y square is equal to 1. This is an equation of hyperbola. X square plus y square is equal to 1 is equation of circle. Now the curve hyperbola is this one. This is origin, and a hyperbola has 2 branches. One branch we can show like this, hyperbolic function. One branch will be of this side, and another here is 1, and here it is minus 1. So another branch of hyperbola. And a point, if you consider a point as hyperbolic cos t, a point on this can be considered as on this hyperbola, if P is the point, and if P is the point, hyperbolic cos t, hyperbolic sin t, then that point P satisfies this equation. x square minus y square is equal to 1. That means hyperbolic cos square t minus hyperbolic sin square t is equal to 1. Or in place of t we may see x. Hyperbolic cos square x minus hyperbolic sin square x is equal to 1. So this is the difference in the identity and also in the curve. X square plus y square is equal to 1 represents circle, and therefore usual trigonometric functions are called circular functions. Sin x, cos x, tan x, cot x, sec x and cosec x. These are circular functions if you don't write h. And if you write h, then that becomes hyperbolic function, because these functions are related on to this hyperbola, rectangular hyperbola x square minus y square is equal to 1. You have studied hyperbola in conic sections in last year 12th standard, and the curve has two branches, and if we take the coordinates of a point as cos hyperbolic t, sin hyperbolic t, then that lies on this curve. Here this cos t sin t lies on this circle. So this is the relation or the difference between circular function and hyperbolic functions. Now we have written identities, and these identities can be proved using the definition only. So a few of this we will see, and the first we shall prove this hyperbolic cos square x. Proof for the first. What is the LHS? These are these remaining are the formulae formed from only this identity. So the main identity is only this one. Others will follow using these all formulae. Only what we have done, this hyperbolic sin square x is transferred on that side. We can write 1 plus hyperbolic sin square x. And similarly, this is hyperbolic sin square x is transferred on this side, 1 is transferred on this side, and these only are the shifting of terms. And these all, that means these 5 formulae are obtained from the single formula, and therefore we have written below this. Now we will prove this one, and for this purpose we consider the RHS. So what is RHS of this? RHS is hyperbolic cos square x minus hyperbolic sin square x, and we want to show it is equal to LHS, that is 1. So this is equal to, we use only the definition. What is the definition for hyperbolic cos x? This one, and we write its value in bracket, e to the power x plus e to the power negative x divided by 2, its whole square, minus hyperbolic sin x, and this is e to the power x minus e to the power minus x divided by 2. So these are the only important definitions to be remembered, and identity is this one. So further this can be simplified. Now you see that the denominator is 2 but it is square, and therefore the common denominator can be written as 1 by 4, and we write the expansion of these squares in bracket. So if I use bigger bracket, so what is the expansion of e to the power x plus e to the power minus x, a plus b whole square formula. Square of this, that is e raised to 2x or e to the power 2x, and middle term is double positive e to the power x, e to the power negative x, that is middle term, and third term is e to the power negative x square, or that means e to the power minus or negative 2x, and this is the expansion of the first, minus expansion of the second, and that is e to the power 2x. There is middle term is negative now, minus twice e to the power x into e to the power negative x, and next the third term is positive, square of the third term e to the power negative 2x. So this is expansion. Now we may observe this is equal to 1 by 4. Now you see what happens in the difference of these two, subtraction of these two, e to the power 2x and e to the power 2x cancels. Similarly, e to the power minus 2x and minus of e to the power minus 2x cancels. So the first cancels, the third term cancels, and what remains? Now this doesn't cancel because this minus of minus, double negative, becomes positive. And what is this product? This product, e to the power x into e to the power negative x. By using laws of indices, there will be addition of indices, e to the power x minus x, that is e to the power 0, and we know e to the power 0 is 1. So therefore this is plus 4 in bracket e to the power 0, and that is 1. So therefore it is 1 by 4 into 4, or which is equal to 1, and that is the LHS. So thus this proves the first identity. What we have proved is hyperbolic cos square x minus hyperbolic sin square x is equal to 1, and this completes the proof of the first identity. Now these you can observe only what these are shifting of terms. Here how to get this formula, similar to circular function, hyperbolic sec square x, and to get the hyperbolic sec square x we divide this relation by hyperbolic cos square x. So hyperbolic sec square x will be obtained here, and this is 1 minus hyperbolic sin square x divided by hyperbolic tan square hyperbolic cos square x, that is hyperbolic tan square x, by this formula. So dividing by hyperbolic cos square x we get this one, and here how to get this hyperbolic tan square x formula? From this only. See, hyperbolic tan square x is transferred on this side, and hyperbolic sec square x is transferred on this side. Only the shifting of terms and division by sum. And here to get this result, we divide the relation 1 by hyperbolic sin square x. So 1 upon hyperbolic sin square x is cosec square x. Yes, cosec square, hyperbolic cosec square x, and this becomes this will be cot square, hyperbolic cot square x minus 1, and we obtain this formula. You may verify these results, and now this can further be easily proved. Hyperbolic sine of negative x is equal to negative of hyperbolic sine x. What is the change? We can consider replace x by minus x. If we replace x by minus x, this becomes e power minus x, and this becomes e power plus x, and therefore there is change in sign only, and thus second, third results are easy to verify. You can verify these also. Only one of these we shall prove, and we consider the last one. Other can be proved yourself using the definition only. Now the one of this, here the two results are combined, 6 and 7. If there is plus sign, we get one formula. Hyperbolic cos x plus y is equal to hyperbolic cos x into hyperbolic cos y plus hyperbolic sin x into hyperbolic sin y. And if there is minus sign, corresponding sign will be minus. That is for hyperbolic cos, and similarly for hyperbolic sin. Circular function, the sign is opposite. Terms are similar, but the sign is opposite. Here the same sign is there for both hyperbolic cos and hyperbolic sin. You compare these identities with circular functions. What is the change? Here instead of plus sign there, here is minus sign, and we have seen the curves are different. For circular, the circle; for hyperbolic, the hyperbola. And now from 7, in 7 the first formula we shall consider RHS is, and instead of RHS we consider the LHS. That will be easier to prove. Either prove RHS is equal to LHS or LHS is equal to RHS. Now we consider LHS, that is hyperbolic sin x into hyperbolic cos y plus hyperbolic cos x into hyperbolic sin y. Plus formula we are considering, the formula which involves plus sign, and this will be equal to, what is the definition for hyperbolic sin x? You see here it is, and that is e to the power x minus e to the power minus negative x divided by 2 into hyperbolic cos y, that is instead of x use y, and therefore it is e power y minus, or it is plus e to the power minus y divided by 2, and this is plus hyperbolic cos x. Again this is e to the power x plus e to the power negative x divided by 2, and hyperbolic sin y e to the power y minus e to the power negative y divided by 2. So these are the formulae we have used, and now we will simplify this. See, for the product, again you see the common denominator can be taken as 1 by 4, 2 into 2. So denominator is 4. So 1 divided by 4. And in bracket, I shall write this product here in bracket. And then again 1 by 4 is throughout common. So I shall write the product of these two in bracket. And you see this is only the arithmetic simplification. And this is e raised to x into e raised to y. We have to use the laws of indices. Laws of indices can be used, and this is e power x plus y. E to the power x into e to the power minus y. That is plus e to the power x minus y. Now the product of these two. It is negative sign, negative or minus e to the power minus x plus y, or we may write e to the power y minus x. And last one is again negative, negative into positive is negative, e to the power negative x, e to the power negative y. Negative sign is common, e to the power negative x plus y. So this is the product of these two. Now the product of these two terms, there is plus sign. So plus, I shall write again in bracket, product of these two is e to the power x plus y. Next is minus e to the power x minus y, product of these two. And now it is plus sign e to the power y minus x, positive, negative, sum of indices. And the last is plus into minus, that is minus, and e to the power negative x, e to the power negative y, that is negative sign is common, x plus y, and close the bigger bracket. Now you see what remains in the bracket. 1 by 4 is common, and you see there is addition for sign, and therefore these terms get double. And what about this second term in each bracket? They are opposite of each other, cancel. So this is y minus x minus, and this is plus, so this term also cancels. And last term has the same sign, so therefore it will be added, double, it will be double term. And the first is double, last is double, middle two of each bracket cancels. So that is twice of e to the power x plus y, and I write now 2 common, e to the power x plus y, and this is minus 2, 2 is taken common, e to the power negative of x plus y. And you see this is 2 by 4, 2 by 4 is 1/2, and what remains is e to the power x plus y, etc. So I shall write here that is equal to e to the power x plus y minus e to the power negative of x plus y divided by 2. And what is this? You see, this is exactly hyperbolic sine of x plus y. In place of x, here is x plus y. Negative sign is there, negative of, in place of x, x plus y. So you should compare the terms and write the function accordingly. So therefore this is hyperbolic sine of x plus y, and that is what is the left side. We have considered positive sign, and if you consider negative sign, we will get negative sign on the left side also. And this is LHS. And thus we have proved the last result. We have proved first and the last. Now you should try the remaining result. Only these definitions are to be used and laws of indices. We have only the multiplication is there. For these 6, 7 or the 4, 5, 6, 7, you try right side to left side. That will be easier. And these are very simple, you should try. So thus we have defined 6 hyperbolic functions and some fundamental identities of hyperbolic functions. So remaining results you should prove and try yourself. So now we want to consider the derivatives of hyperbolic function and inverse hyperbolic functions. That we shall see in our next lecture. Thank you.